And welcome to Math Life. This is the quick review, solving mixture problems with systems, so a system of equations. Let's get right into it. A gourmet popcorn results when popcorn that costs 75 cents a pound is mixed with chocolate costing $2.80 a pound. If 14 pounds of the mix costs $14.60, how many pounds of popcorn and chocolate were used? All right, so what's the formula on these? It can vary a little bit, but basically it's the amount of each substance, either the price per pound or the percent, depending on the type of problem, and usually the total cost or total amount. So in this case, those are our columns. So we have 3 columns, but we also want 3 rows. And why do we want 3 rows? Well, you need a row for the popcorn, a row for the chocolate, and we need that 3rd row for the mix. All right, so let's go through and fill in our chart. Remember, fill in the variable column first. So the question asks how many pounds of popcorn and chocolate were used. Okay, so the amount of popcorn is one variable x, and the amount of chocolate is y. Solving this using a system of equations. Okay, let's look through now and fill in, see if we can fill in the rest of the spaces. The amount of the mix, it says if 14 pounds of the mix. Okay, so 14 pounds of the mix, so the amount is 14. Cost per pound, it gives us that. Popcorn, 75 cents per pound. And chocolate, $2.80 per pound. 2.8, right? You can put 2.80 if you want, don't need the O in the end. And the mix is $14.60. And again, I could have just put 14.6. Okay, cost. And I just looked at that and said, wait a minute. The cost of the mix, total cost of the mix is $14.60. This is $14.60. Okay. Now, how do I get the cost of the popcorn? Well, again, why do I include my equal sign in my charts? Because it helps me to remember that oftentimes the amount times the price per pound gives me the cost in the chart. And that's what I want to do. All right, so I'm going to do x times 0.75, and that's going to give me 0.75x. I'm going to do y times 2.8 for 2.8y. Okay, great. Charts filled in. Say, Mr. Scarfi, you don't have the price per pound for the mix. I don't need it. I don't need this. Sometimes you'll have a blank in the chart. Why don't I need it? Because look, here's one equation, the amount equation. And here's the other equation, the cost equation. And the nice thing about mixture problems is this. The equations are always total equations. So here's the first one, x plus y equals 14. Cool. Here's the second one, the cost equation, 0.75x plus 2.8y equals 14.6. Okay, there's my 2 equations. How do I want to solve? Substitution or elimination? I say substitution. Let's move the y to the other side. Now I've got x equals 14 minus y. Let's sub that in. I'm going to switch over to blue here. So where the x is, I got to sub that in. All right, and what am I subbing in? 14 minus y. Okay, so calculator, 0.75 times 14 is 10.5. Minus 0.75y plus 2.8y equals 14.6. Look, you got a bunch of decimals, but it's no big deal. You got a calculator. If you want to, you can multiply by 10 and get rid of all the decimals. But again, not so hard to handle. All right, so we end up with 2.05y when we add up our like terms. And when I add a negative 10.5 to both sides, I get a 4.1. All right, divide both sides by 2.05. So I got 4.1 divided by 2.05, and I get y equals 2. Now, what is y? And what is this 2? Well, again, I just go to my chart. Y is the amount of chocolate. Okay, 2 pounds of chocolate. Cool. Now, how do I finish? Again, I just go back to this. X will be my 14 minus my y, which is a 2. and X is therefore 12. And what is X? Go to my chart. Okay, 12 pounds of popcorn. Hey, that's how they're done. That's the idea. Now, let me remind you of one thing. A lot of times in the percent type problems, make sure that if you have a pure substance, then it's 100%. Any pure substance is 100%. Other than that, that's how you do them. Hope you